Let's understand the different types of arc welding. First is carbon arc welding or CAW. Carbon arc welding or CAW is a welding process in which heat is generated by an electric arc struck between a carbon electrode and the workpiece. The arc heats and melts the workpiece edges, forming a joint. Carbon arc welding is the oldest welding process available. If required, filler rod may be used in carbon arc welding. End of the rod is held in the arc zone. The molten rod material is supplied to the weld pool. The advantages of carbon arc welding are like low cost of equipment and welding operation. High level of operator skill is not required. The process is easily automated and low distortion of workpiece can be seen. However, certain disadvantages of carbon arc welding is also present. First being the unstable quality of the weld due to porosity, and the carbon of electrode contaminates weld material with carbides. The carbon arc welding has been replaced by TIG or tungsten inert gas arc welding in many applications. Next we have SMAW or shielded metal arc welding. The shielded metal arc welding or SMAW is also known as manual metal arc welding or MMA. Flux shielded arc welding or informally as stick welding. It is a manual arc welding process that uses a consumable electrode covered with a flux to lay the weld. An electric current in the form of either alternating current or DC or direct current from a welding power supply is used to form an electric arc between the electrode and the metals to be joined. The workpiece and the electrode melts, forming a pool of molten metal which is known as weld pool that cools to form a joint. As the weld is laid, the flux coating of the electrode disintegrates, giving off vapors that serve as a shielding gas and providing a layer of slag, both of which protect the weld area from atmospheric contamination. Next we have GTAW or gas tungsten arc welding. The gas tungsten arc welding is what we call tungsten inert gas welding or TIG welding. It is an arc welding process that uses a non-consumable tungsten electrode to produce the weld. The weld area and electrode are protected from oxidation or other atmospheric contamination by an inert shielding gas, which is generally argon or helium. A filler metal is normally used, though some welds known as autogenous welds or fusion welds do not require it. When helium is used, this is also known as heli-arc welding. A constant current welding power supply produces electrical energy, which is conducted across the arc through a column of highly ionized gas and metal vapors known as plasma. TIG or GTAW is most commonly used to weld thin sections of stainless steel and non-ferrous metals such as aluminum, magnesium, and copper alloys. The process grants the operator greater control over the weld than competing processes such as shielded metal arc welding and gas metal arc welding, which allows for stronger and higher quality welds. However, TIG is comparatively more complex and difficult to master. And furthermore, it is significantly slower than most of the other welding techniques. Next we have gas metal arc welding, in which consumable wire electrode is fed through wire feed rolls, which creates a gas shield over workpiece. Next we have submerged arc welding. Submerged arc welding is a common arc welding process that involves the formation of an arc between a continuously fed electrode and the workpiece. A blanket of powdered flux generates a protective gas shield and a slag, which protects the weld zone. A shielding gas is not required in case of SAW. The arc is submerged beneath the flux blanket and is not normally visible during welding. This is a well-established and extremely versatile method of welding.